Hi, I'm Matin Jouzdani from IBM. Martin without the R, I always say that, just to get it out of the way. I look after big data in IBM's consulting practice. Now, like the other speakers, I was given a very long title with some detailed feedback to really talk about big data strategy. What does it mean? So then I realized, actually, I've got the slot just before lunch, so there's a risk that I'm going to get increasingly hungry, agitated people. So I tried to take a little bit of a step back and try to make it a bit more light in terms of agenda. So I've come up with what I call the 7 golden rules to building a big data strategy. Do they come out gold? Yeah, probably. Maybe yellow or amber rules for building a big data strategy. Now, I have been fortunate enough, actually, to spend almost all of my time in the last year solely focused on big data. So that's implementing projects, designing strategies with clients, rolling up my sleeves and analyzing data myself, and having lots and lots and lots of conversations like this. So that's my first disclaimer, is that is built up from that hands-on experience over the last year or so. And of course, I won't claim that this is an exhaustive list. And hopefully some of this stuff will spark other discussions, because for me, big data is one of those areas where there aren't actually that many empirical universal truths yet, so plenty of opportunity for debate, some on the actual emotive side. So there are no words there yet, so don't worry, it's not Emperor's New Clothes. If you can't see it, it's because I haven't revealed them yet. So the first one, actually, I think this is one of those areas where I guess we're mostly business people here, and I hold my hands up. Business, technical, I tend to be more on the business side, but this is definitely one of those areas where getting to grips at some level with the technology is really, really important. Because in my view, and shared back at IBM, big data, taking beyond the hype cycle that we saw earlier and the buzzword in the industry, there are some really important technology drivers causing the shift. It would be impossible for me to do a talk on big data without mentioning the 3 V's. I'm very glad it came up today, because I see this as an extremely good way of understanding the concept. Big data actually for me is a misnomer in some senses, so I don't tend to talk an awful lot about volume, because on its own that's not really an interesting phenomenon, and I'll come to the data warehouse shortly. But what we're really talking about is where variety and velocity enter into a new type of analytics challenge. So variety, moving out of the tabular, structured database sense of data and more into what I would call semi-structured data forms, where we've not put the data through a rigorous ETL process, or indeed we never intend to, because it's image or video or something like that. Something which I think tends to be underplayed actually in big data is the concept of velocity. And that's because the underlying technology is far less ubiquitous. I'm sure everyone in the room has heard the words Hadoop, or massive parallelized processing of data, which is associated with variety and volume, but fewer have come across stream computing, which for me underpins the velocity component of big data. So I have a picture which summarizes for me what I would consider the big data technology platform. Just a way of sort of unpacking the 3 V's, which are along here, and I'll address those in a moment. This will be the only time during this talk that I will actually make specific reference to IBM technology, because I'm so bloody proud of it. Not that I invented it, but I'm just proud to be part of the organization that has it. But of course, I will say that there are alternatives to all of these. So Hadoop is probably the most famous, the most well-known, often talked about technology driver in big data. And what Hadoop is allowing you to do is perform hugely scalable analysis of data of multiple types. And that's really important here. I'll talk about the data warehouse in a moment. They've got it nailed in terms of being able to analyze millions, billions of observation in complex data models. What Hadoop is, the challenge that Hadoop and associated solutions are trying to solve is what about the variety component? When you're combining data that is structured, semi-structured, and unstructured. I'll come back to that a little later. I mentioned stream computing to address velocity. Now this for me is a completely different type of doing advanced analytics on big data. The idea that you can analyze data in motion. Not having to gather the data, perform batch processing, at-rest analysis, but actually analyzing, and I don't mean counting or applying basic rules, but analyzing data in real time. And then, of course, the data warehouse. For me, a big data project could simply be analyzing huge amounts of volume that we've already loaded into a data warehouse. I did a big data project this year where we did exactly that. We had a client who had previously been ignoring a really rich source of their data. It was sitting there in the warehouse gathering dust, and they wanted a quick, rapid proof of concept as to whether that data had any value. Now, some of the other stuff to talk about, veracity, because there are other V's. There are probably about 3 other V's, depending on who you ask. And I'll revisit veracity a little bit later, because what we shouldn't take away from this is that big data means seek and gather and integrate as much data as you can, and forget about all of those data quality master data rules. We're definitely not saying that. Similarly, we have the concept of visibility or visualization, particularly when you're integrating data types that don't fit into a spreadsheet or a table. It becomes even harder to visualize that, both as an analyst, trying to get the sense of what joins, what queries, what in-depth analysis do I do, but then also as an end user. How do I surface that to an end user and help them make a real end user, a non-techie end user, if you like, and help them make actual decisions? And the final V, not forgetting, probably the most important, is value. For those of you who've started getting into big data, and particularly in Hadoop, it's actually really, really hard. A lot of these applications are sort of the domain of so-called data scientists, and I'll revisit that a little bit later. People who can program in Java, people who can pick up new querying languages on the fly and don't look at graphical user interfaces and are just there in command line. They are, for me, a barrier to releasing the proper value of big data here. And so this concept of accelerators, pre-built packages, pre-built code, routines that can be deployed into enterprise-grade big data applications and lower that time to value. So, technology. Very, very quick overview because I'm not going to claim to be a techie. The second is, as you broaden your understanding of the technology, actually give some thought to the type of business problems that big data can address. And this is a really, really fertile, growing field of discussion and debate. I tend to categorize the applications in 3 ways. On the left here, examples of just brand new things, things that not necessarily were being imagined before the advent of big data technology. So for example, volume and variety and velocity challenges, capturing GPS signals from vehicles, public routes, bus routes, anecdotal evidence and tweets about how people move, and combining that to understand real-time traffic flow. Or even in the stream computing case, analyzing millions upon millions upon millions of, say, CCTV, phone patterns, etc., to analyze and detect threats in good time. Completely things that weren't actually possible without this technology. In the middle, we start to just talk about what I would consider doing the same sort of stuff, but bigger and better. I think one of the other speakers mentioned this as well. And an awful lot of the big data applications, they start to breach into business analytics as well. I'm not going to sit here and say that retailers can do propensity and churn modeling in a new way because of big data. But what they are going to be able to do is add more granularity, more data points, more history into models. And for me, that's a perfectly valid and interesting application of big data. Similarly, for fraud and risk detection, what big data analytics is going to allow organizations to do is, again, add more to the models and come up with richer patterns that can be discovered. And then when you enter with stream computing, act on those in real time, not building up batches of data and running jobs 24 hours, 7 days, or even more further behind. Where it gets really cool, and where I've tried to spend most of my time over the last year or so, is when you get into sort of model innovation, doing things in new ways. So we've heard a lot about social media today. Big data has made me a believer in the potential of social media to understand customers, whether it's sentiment, whether it's buying indicators or whatever. Big data technology starts to make all of that very, very real. And when I say real, I mean not simply counting keywords and producing pie charts along that way, which fortunately we've not heard about today. We're hearing about interesting applications. And then finally, say in the telco space, I believe telcos have a unique opportunity in big data. to, for the first time, actually leverage the enormous amount of information that is passing through their network. So, a couple of specifics then. I talked about Hadoop. One of the things that I'll want to draw attention to, the sort of problem we're seeing Hadoop being solved, is exploration. One of the things I keep telling my clients over and over again, most organizations already have a sandbox, a playpen, an area of their data warehouse set aside where analysts can explore, discover. Often, depending on the quality of the exploitation layer and the rest of the business, that ends up being the operational place for analysts to do their work, and a bit of a disaster. And we have lots of projects like that. With Hadoop, with the fact that you can scale up so cheaply, so easily, and integrate sources of different types, this starts to become a far more powerful way of doing that ad hoc analysis. And not only helping the analysts get to the data they want quickly, but actually helping the architects. It is actually, these days, for all of the advances we've made in what I'd call traditional analytics, it's still very, very hard to go from source to exploitation layer through the ETL and integration journey. It's hard, it's costly, and takes time. With architectures like this, ETL architects, solution architects can make judgments about the way to integrate these data sources with this sort of exploratory technology. Just to wake everybody up, a moving picture. Stream computing, again, the type of business problem that this wants to solve, and I think this is one where we are, the conversations I have with clients is trying to open their imagination to the sorts of things this can do. The key words, in-memory and ultra-low latency and analytics. What I mean by in-memory, as it suggests, this is analyzing data from source and deliberately complex, unstructured, semi-structured sources of huge volume, analyzing them in memory. So we're not storing the data. We don't have to sit the data down, gather it, clean it, put it into a table. We're just letting it flow past, but analyzing it as it's flowing past us in memory. Enormously scalable architecture that can deliver the ultra-low latency needed. And then I said analytics as well. I mean, this is a very mocked-up architecture for a stream computing. Each of these red blobs isn't a tell me when the value is greater than 10. Each of these red blobs can be a model that has been built, a text analytics routine, a means of interpreting an image and pulling out whether there's a face in there. Then it just becomes a limit of imagination as to how complex can you make this, how interestingly complex can you build this application to be. And then the most important thing when you get to the end and you've extracted the insight you're interested in, you don't need to keep any of this data. When you're searching for the needle in a haystack, you don't want the hay. You don't want any of the hay. You just want the needle. So think about the reduction in time to actually plow through and assess whether any of that data is ever going to be useful. So trying to bring all of that together, if we imagine an example where we did want to use stream computing to assess whether a data source was going to be of any value to us. Let's take a completely artificial example, an internet banking application. We want to understand whether failures are causing failures on the server side, social media indicators, where the people logging in are causing any problems that we need to act on. All of those signals, particularly the server logs, we don't want to put into our expensive, valuable data warehouse. So what we might do is load all of that data into a Hadoop environment. And then we can perform exploratory analytics. Now let's say we discover a model that tells us, in certain circumstances, this is something you're going to want to act on because you're about to expose a lot of customers to churn because they're having a bad experience. You can take this model, put it into the stream. And now what you're doing, as this huge amount of data that you're not really interested in, you're not really interested in keeping server logs in your data mart, you're not really interested in clickstream analysis or tweets or anything like that, but you are interested here in combining those data sets into such a way that you can score your model, and then sending the model results and any associated data you like into the warehouse so that analysts can act on it. Right, so the types of business problems it can solve. The next thing, I promised to come back to veracity, because it's quite an important thing to mention. One of the things we like to say in the business, we've been saying it for a while, is that 80% of the world's data is unstructured. Well, actually, it's more like the fact that 80% of it is uncertain. If we think about, on this chart, the amount of data that organizations have rightly spent a lot of time and effort in cleaning up and making fit for decision making, enterprise data, is actually starting to pale into insignificance in terms of the amount of data that's possible to be exploited. And this is extremely important to bear in mind, because what we're not saying is indiscriminately go and gather as many internal, external, new data sources as possible, and you're on the road to big data. The focus on veracity and the underlying challenges of some of this data become really, really important. I'll come back to the telco example again. Across the world, we're seeing all of our telco clients get really interested in something called location analytics. The ability to take the signals that come out of the network and understand where people are. Without going into too much detail, it's much harder than it sounds, perhaps reassuring, because what our mobile phones do is tell the operator which cell towers nearby are we interacting with, which in itself is not nearly enough information to be able to pinpoint us, which is, again, kind of reassuring. So in order to leverage that big data, once you've got past the scale challenges and you've potentially loaded billions of those data points into a Hadoop cluster and you're trying to make sense of it, you're going to then need to roll out some heavy-duty analytics to be able to actually build those models that are going to get any value out of that data. One final thing I'll say on information governance is I want to completely reject, for what my view is worth, the concept that big data platforms are here to replace or step on the data warehouse. I think for a long time, the data warehouse, the database, or your single source of truth, wherever it lies in your organization, needs to be the place where operational decisions are made in your organization. The big data platform is giving you other options. It's giving you ways that, as I said before, you can have a new, flexible way of doing exploratory analysis. You can test some of your traditional and some of the new sources before you decide to integrate them or not. It's not the Wild Wild West here. Information governance is going to remain as important as it ever was. So, business and IT. I've talked to a lot of people in IT about big data. They're reading the news, they are studying their field, and they're looking to put a big data strategy together. And time again, it's coming out of IT. And some of the things they're coming into contact with is that some of the nuances around how our organization's going to approach the problem. So we're moving away from some of the structured, repeatable, linear steps that we get in the data warehouse, that we get in our ERP landscapes, and moving towards the concept of exploratory analysis in an unstructured environment, incorporating data sources that we used to keep at arm's length or roll up in some other application, and actually the integration of new sources. So that, combined with the fact that IT managers seem to be getting ahead of this first, I've noticed this sort of split in the delivery model. So where we're moving from the business turning up and saying, you know what, I want to build a new report that predicts how many widgets we're going to sell next quarter. So that's a data mart. I want customer ID, I want the product table, I want the number of marts, and we're going to have granularity of 30 days. So IT goes away and builds it. You load the source data, you get your ETL guys to build the exploitation layer, and you come back to the business and they say, that's great, but now can I have this too? And that iterates for time and time again, and keeps people like me in business and keeps all of us very busy. What I've seen a lot of with big data is this concept of build it and they will come to some extent, which is risky, and I'll come to that in a moment. But the idea that the monkey is now on IT's back to build these big data platforms, build these capabilities, and then push that capability to the business so that they can go and explore and ask the questions that need to be asked. Because, I've been studying this for a year, and I don't go to my clients with a list of business applications for this. I go to them with, as I've said before, here's the technology, here's the transformative potential in certain domains. Now, business, you need to chew on this, mull it over, and the applications will come to you. But until they've got this platform, the technology foundation, it becomes very, very difficult to start that journey. Linked to that, I've been on maybe 2 or 3 of these projects where IT have got it spot on. They've got the CIO or the IT director saying, I'm going to build a big data platform. It's going to be fantastic. And they did bring in, they brought us in, we helped, we ran the analysis, But they lost focus on these two things. And this isn't a big data domain. This is just any business analytics or indeed any IT change. IT these days do not fund technology end to end. They're going to create the platform and they're going to invest the skills. But ultimately, if there's no sponsor in the business and the value has not been proven, then you're going to flounder in your phase one. I'm not going to dwell on the method too much, but I've done a lot of phase ones where you're defining your opportunities, you're workshopping, you're coming up with the wonderful ideas, you're getting enthusiasm, and then we're prioritizing and making recommendations. I cannot emphasize enough how important it is to don't forget about the business case. Hype is not enough to make investments, and I believe that even though a lot of this is brand new, we can still work through those business case disciplines that we all know and love, make sure that there's a solid business case there, and make sure you know what phase two is going to look like. I've not come across a business sponsor yet who has said, you know what, I'm not going to do a POC that IT is funding. Well, hang on, why wouldn't they? IT is funding the POC. All I've got to do is step back, wait for the results, and I've ticked my personal objective that I've tried out big data. Well, let's make sure we understand what phase two looks like. Let's make sure we have a plan for embedding that and sponsoring that through, because we all know and experience every day that business analytics is tough. This stuff's even tougher. Now, we heard about data scientists today, and indeed we heard from a chief data scientist, and I'm pleased to say I agree with the point made, if I understood it, about data scientists already being in your organization. Because there's this fact of life out there that big data often is associated with coding, and the analysts have to code as well. I can think of 3-4 new querying languages. Even if you're SQL trained, you're still going to have to go and learn a new skill, be it Pig, be it Hive, be it whatever. You're going to have to go and learn a new skill. And that's only if you just want to be able to lift and shift and move data and do the basic manipulation. If you want to do any of this stuff, you're going to need to get into the realm of accelerators that need developers. They need PhD scientists who've been studying computer science for years and years and years. And actually, these days, if you're a grad coming out of university with this sort of skill, you could start to walk into six-figure jobs, because some of the organizations I've witnessed who are having a go here are putting an over-dependence on this type of resource, where actually I think that the data scientists are already sitting in your organization, and they're really cool. That's why I put the shades on the guy. But for me, it is the mathematician, not necessarily the mathematicians, people who just are numerate, the business analysts that we already have in our organization. If they can embrace some of the IT concepts here and continue to embrace their deep subject matter expertise on business, they are the ones who are going to make your big data platform come alive. And IBM has actually invested a huge amount into our big data products to make the experience to an analyst look and feel like it does already. So our Hadoop system comes with a spreadsheet-like interface. Our accelerator platform is drag and drop. There is coding behind the scenes if people are that way inclined, but for me as an analyst, I like drag and drop. I like SQL. I like only typing 3 or 4 lines, and then I'm glazing over because I want to just get to the point where I'm manipulating data. And equipping the data scientists with the platforms that IT have built and nurturing them through the journey, because they are the ones who are going to make it work, is absolutely key. So, last point, and this is something that one of my clients used to say to me over and over again, medium data or small data. This is one of those, the point was made earlier, is that there are now 2 types of organization. Some of these internet startups or new companies that have emerged in part because of the big data phenomenon they don't have the burden of legacy. So they're not having to make the transition, the cultural, the organizational, or whatever you want to call it. But for the rest of us, who are in organizations that have been there for years and years and years, I actually think that big data is going to have all of the characteristics that made you successful in your traditional, very unfair word, in your traditional business analytics challenges. And I'll just give you a couple of thoughts based on a piece of research IBM did last year into what makes analytics, what makes organizations excel in the realm of analytics. And long story short, our research findings came down to 3 things. One of them is that there is a widening divide. which was the name of the paper, being created by analytics, companies competing and succeeding on analytics and leaving those who don't behind. And we found 3 types of competencies that existed in those organizations consistently time and time again, albeit there are slightly two broadly different ways of achieving that goal. And I will get to the point, I promise. Now, those competencies, for me, start to look an awful lot like some of the things we've talked about. Not forgetting data management practices, making insights accessible to the whole organization, robust tools and solutions, analytics as a strategic asset, and that's what I was looking for, skills developed as a core discipline, enabling those data scientists to fully grasp the big data revolution. And as I promised, we discovered broadly 2 paths of getting there. The collaborative path, which is sort of sponsored at the enterprise level, brings everything from a top-down sort of strategy. And then we've got the specialized path, where lines of business are putting their necks out and going down a very specialized route and growing out from there. And actually, the specialized path starts to look an awful lot like some of the things I've already talked about with big data. So learning the art, the discipline of consolidating and integrating information that is internal, external, structured, and unstructured. Getting to grips with this concept of analytics accelerators that need to be at the heart of the big data platform, not simply adopting the frameworks and not contextualizing it. And finally, empowering data scientists who are already within the organization to drive out and be the engine behind your big data initiatives. So the point here is that success in this space is going to look an awful lot like the characteristics that brought you success in business analytics generally. So, there are my 7 keys, 7 rules, if you like. Learning about the big data technology. If anything, just for interest, because this stuff's really, really cool. Understanding the types of business problems it can address. So, taking that understanding of the technology, applying it to your own business domain, and starting to open up the imagination. You'll be astonished at the ideas that will come in a workshop, in a discussion, once people start to understand what this stuff can really do and go beyond the big data hype. Veracity and information governance. We're not trying to compete with the data warehouse. We're not trying to compete with the data mining, business intelligence tools here. And we're not trying to go back on all of those disciplines, the single source of truth that it took so long to get the business aligned on. On that, the relationship between business IT is going to be as important as ever. I'm not saying it's going to completely go 180, but there are going to be some subtle differences. The build it, they will come mentality, I think, is going to be quite important. Sponsorship and value, making sure that we don't stop our investment in this after phase 1, that IT are getting their ducks in a row in terms of people in the business to carry this forward, and never ever forgetting that hype is not enough for this to be something to do in your organization. Never forget the value. Small and medium data, making sure that the experiences that made a success of your business analytics and BI initiatives continue to be those that make a success of your big data initiatives. And finally, those data scientists. Please don't go and hire a PhD rocket scientist. Find the ones who are in your organization, nurture them, teach them about these tools, and give them the opportunity to blow your socks off. And that's me. Are there any questions? Yes. Okay. I completely agree. So I actually think that a location and analytics project shouldn't simply take one source of data. I think the key is absolutely correlating might not be the right word, but leveraging other data sources. I'm sorry. Yeah. Well, hopefully not us today. Any other questions? I'm conscious that I'm between you and lunch, but okay, yes. Yeah. So I've seen organizations consider using Hadoop as a way of accelerating the design part of ETL, or even starting to use it as a staging area before ETL. I don't think Hadoop architectures are ever going to be as robust as you require in the data warehouse. And then some of the things that make Hadoop such a Hadoop cluster, a Hadoop environment so powerful for mining and exploration start to count against you. Because what you're trying to do with a Hadoop environment is have lots of collaboration, not being rigid to the data model, and just through the Hadoop file system, getting analysts and data to meet. That sort of approach for me doesn't work in a data warehouse, which is why we always hyphen off, we always push off to one side the sandbox, because we don't want that sort of important and useful working arrangement to affect the fact that we've got to keep the data warehouse holy, if you like. Does that answer the question, or a different question? Okay. So I'm here all day. We're in a stand there. I'd be very, very happy to continue the conversation, if only for people to disagree, because as I said before, these are not, I don't think the rules are set yet, and I think that's what makes this field very exciting, because the rules are there to be set. So if you want to debate or disagree, please, I'd be fascinated to hear from you. Thank you very much for your attention.